Well, I want to welcome our teleclass audience for today. This is April 18th, 2019, and we have a very good program for you today. My name is Lynn Seeholster. I retired from CDC about 2 years ago almost. Anyway, our speaker today is Andrew Streifel. He is well known to the teleclass audience. Andy just retired from the University of Minnesota, where he was based in the university's Department of Environmental Health and Safety. And he has had a long career, more than 30 years, ultimately culminating in being a well-known consultant on the built environment for healthcare facilities, including ventilation, water, ventilation as an agent for infection control, and other matters relating to design of facilities and the installation of systems. So with that, let us welcome Andrew Streifel, who is presenting today on hospital renovation, infection control, best practice, training, and experience. Andy, you have the floor.
Thank you so much. I guess I have the air, but it's such a pleasure to be able to do things like this, and I'm so blessed with the opportunities that I've had in being an investigator. Having read the Hardy Boy books about being detectives really inspired me, and when I started work as a kidney dialysis technician back in 1969, I was absolutely enthralled by what I saw, what I was given the privilege to participate in. And as I transitioned into, after getting my master's degree in public health and institutional environmental health, I really found the niche in our bone marrow transplant immune-compromised patient population. And really that was the reason for my existence at our institution as we learned to manage the severely immune-compromised patients. So with that, I started to work very closely with facilities individuals, Jim and Chris here, the electrician and facility manager, as well as the construction team, the foreman of the carpenters, as well as the mechanical people, are folks that you're looking at. And they really were my assistants in dealing with the program we're about to see. Next slide, please. So what we are really after, and what we really need to remember, is we must be respectful of our patients. We're there because of them, not because of anything that I've done. Our contractors need to control aerosols, so do we as infection preventionists. We need to maintain a clean environment during construction, prevent water damage, unfortunately, such as the reason why we need to have prompt response to emergencies. Provide documentation, know what we're doing, be trained, and communicate. Communication can't be stressed enough because of the fact that today in a lot of our large tertiary care hospitals, the patients that we see more and more are those that require longer hospitalization and become immune compromised. I've been told by some folks that the spectrum includes every person that comes into a hospital because they all get immune compromised in some ways or another. But the reality is that we're really worried about the ones where we start to alter their physiology, their immune system, when treating things like HIV, organ transplant, malignancy, and then the riskiest of all, the bone marrow transplant. And it was notable today that I see that St. Jude's had developed a means and methods with gene technology to do successful transplantation of the severe combined immune deficiency children. So all of these things are advancing. Slide, please. And what you see during construction is risk. We certainly focus on long-term convalescents, ICUs, immune-suppressed patients that are classified for the reasons that we see surgery, radiation, high-dose chemotherapy, catheters, and areas where we do equipment cleaning. We need to be aware of those, and the procedures in specified areas become an issue, especially if we create a depressurized negative pressure zone to do some kind of effort, and we certainly will recognize those as we go through this. So The procedures at bedside or specified areas are really what are important to realize if there's going to be a breach in the competency of protection in that zone. Issues for environmental infection control, utility outages. How do we do them? How do we plan for emergency outages? Do you keep a 50 horsepower motor around that, as always Murphy's Law would have it, would burn out when you're under construction or under renovation? Ventilation management, and it's always important to remember the simplest approach to this is to maintain clean to dirty airflow. Patient areas are clean and the construction zone is dirty, so I don't like the term negative in pressure, simply negative pressure rooms, because one side of the door is negative and the other side is positive, and which one are we talking about? I really apologize for the fact that I have not looked and put a section in here on water quality assurance, but those of you who were tuned in while we were discussing in the beginning, I will put together a program for this training series on water quality management in healthcare to include construction, new and renovated. When we look at internal construction, which is what we're dealing with renovation, you can see what we've got written here. We really need to be aware of the highest risk times, and preparing the site is that. I worked with a facility just in the last few days where that's discovery period, that reclamation of the Pyxis machine or some other kind of device that's been sitting around for the last 20 years. Suddenly you move it and you see what accumulates behind it, and I'll show you some graphic pictures on that very shortly. So it's a matter of being aware when the risk is greatest. And when we salvage things off the walls, like toilet bowls in some institutions, what's left behind is a moldy piece of material that unfortunately a lot of institutions don't prepare by making the seals before making the barriers before we start removing all of those things. So that's discovery, and discovery, you end up finding a lot of different things. Barrier management, next slide, is really the name of the game. So is it solid or plastic? We tend not to use plastic because some of the folks are arrogant enough or dumb enough, I'm not sure which way that goes, that walk right through the plastic barrier. They think they're more important than anything, and we've had it. I've seen it where physicians and medical staff cut through a construction zone. That's one of the reasons why we use solid barriers and locks on those zones, simply because we can't have anybody getting hurt in an area where they're not trained to walk through and deal with the hazards in a construction zone. So frame barriers, tape barriers, ceilings, doors are all things worth talking about. But the important thing to recognize is smoke control. We'll get into that momentarily, but yet it's all about pressure management. Pressure management is infection prevention. You control the way the particles move, regardless if they're human-generated or construction-generated. And the next slide shows a variety of barriers. The middle one up on top was used to mitigate a mold source in some of our walk-in coolers. When universities, big institutions cut back, they cut back on the temperature of chill water, and then it exceeds the ability of the chill water to remove the moisture. That moisture moves downstream and finds a colder spot, which is our walk-in coolers, and we end up with moldy boxes. And that is, unfortunately, sometimes what we need to be aware of. Whether or not we have chutes containing the dust or double portable filters like the lower left-hand corner, those were in a pharmacy during remodel for the 797 requirements, and we needed 2 of them to maintain the negative pressure simply because there were so many leaks in that space. What's nice is what I call twofer, recognizing twofer. You get 2 for the price of 1, and the Joint Commission has stated in the Environment of Care section that when planning a demo for demolition, construction, renovation, you do a pre-construction risk assessment, and you do all the things necessary to mitigate what you feel in additional environments of care. But recognize that anytime we go into a space to do major renovation, which is what I'm talking about, we go into a period where we disengage the fire alarm system because of the aerosols and the welding and that kind of stuff that are normally generated during a renovation project, and that is interim life safety. They both work for the same goal, controlling the aerosol. In one case, it's something associated with construction. In the other case, it's something associated with smoke control. So that is a very beneficial concept that does not add cost to the project, but requires fire watches, requires extra sensitive management, and the security staff can be trained to simply look for two things: which way is the air moving, and is there any water coming out from underneath the door? So very important. Likewise, on the next slide, 9, we have what we used to put on our all of our demolition details when it came to plans and plan review by the contractor and ourselves, stating some pretty simple things. I underlined a few of them that I think are important. One, dealing with notification and knowing that infection control has a say. We also want to make sure that there's training by the individuals coming in and doing the work. Likewise, we request and we insist, except maybe for critical barriers, which are fire barriers, a need to put flutter strips or some kind of airflow indicator on our barriers so that people recognize what's going on and evaluate that appropriately. Portable filters should be used. They work. We'll talk about that. We should coordinate debris removal and get the stuff out of the building expeditiously, but not necessarily during peak work time. So we need to think about the best times to move supplies in and out. Is that premium time? Is it afternoon time, or is it morning time? And these are some of the issues, and I'm not going to look at all of these and consider these. You can read these as at your pleasure. So what we have is a first day, first hour, what we had when I was there, a first day, first hour. Every contractor, every worker needs to come in and sit down and listen to a whole variety of things, which you can read here, and looking at what we need to consider for the contractor, as well as the prevention of infections during construction on a variety of issues, is roughly a 15-page document, and that, unfortunately, often is all they get. And having done this a few times, those eyeballs go smashing down in the middle of that, and the comprehension is concerning. Looking at slide 11 and the practice in spreading these germs, again, is really important to understand, especially the chain of convection. I can see the eyes closing now. We want to put one thing in everybody's mind, and in our situation in the United States, if the Joint Commission comes in for review and interviews the workers in that construction zone that they walk by, and they ask that construction worker what they do for infection control, it's written in red on this slide. So we can always answer, wash your hands. They might not be able to recite everything that is covered in this training program, but yet they certainly can say that. And we are concerned by the fact that some construction workers in Virginia some years ago complained that one of them developed tuberculosis while in the hospital. But infection control practitioners, being astute, reviewed the records and said we had nobody in the hospital at that time that we knew had a tuberculosis infection. So again, where did they pick it up? McDonald's, Burger King, the hockey game? I don't know. So again, we need to have good records and cooperation between both groups. And on slide 12, we start getting into the patient issues and the bad immune systems, ones that aren't functional, some issues on dust and barriers and vibration, noise, and that kind of stuff. And again, the eyeballs are starting to get heavy because they got a lot of things to worry about, and it's been cold outside. They got heavy clothes on. And again, what do they walk away with? That's why training becomes such a huge issue, and extracurricular training outside that institution is an important thing to understand what HEPA filters are, what traffic control is, what barrier systems are, and why we need to control dust. Next slide, 13, gets into some of the HEPA filters, how many one HEPA filter can cover 20 square feet. We expect our contractors to be able to calculate the number of portable HEPAs that discharge a certain amount of air, and how many air changes we need 6 air changes usually in construction zones during renovation, and how many air changes can we get by how many of these portable filters. So we expect that calculation to be part of it in the faculty for some of that training, and certainly is one that is an expectation. It also recognizes this document recognizes the high risk areas and what we should do. Slide 14, we really look at a risk assessment. If it's 100% risky, it's on the left side or on the y-axis. If we have phases of the project on the x-axis on slide 14, we have a variation in the risk going up. As we tear the unit apart, as we do demolition, slab to slab, wall to wall type of effort, and then we start to build back, we certainly, the infection control risk mitigation response starts to drop. But this is variable. This is extremely variable. If, in fact, during the middle of the project, they decide that while working, someone needs to flood the floors upstairs and the water comes raining down, all of a sudden the risk goes up, or a flood occurs, like a sprinkler head breaks, that can happen, and that may change the risk factors in 8 and 9. So being able to make that risk mitigation response, which is something that is expected in the environment of care, and CMS, Centers for Medicare and Medicaid Services requirements, it's important to be able to respond and understand what risk is and how it changes. Looking at the risk avoidance planning, these are examples of 2 written word signs, if you will, projects that our contractors put together, indicating how equipment was going to come in and out, what the hours of operation are, who to contact, which are all listed in that space. And some of the special precautions include protecting the floors. The one picture on the right is when we were putting in our hybrid operating room with CT and fancy pants things, with very careful instructions on how to get in and out of the operating rooms and avoid disruption. I wish I could talk about this project as a case study, because it was an interesting recognition of things we did and that were good, and things that we didn't do that created additional problems. This particular project was fascinating because they had to reinforce the steel to hang that CT scanning device. And the iron workers did the impossible, trying to put 1-ton beams into the structure to hold up the device. So I have the greatest respect for the work that they do. And certainly in slide 16, we can see what was the first usage of portable filters. And I think it was the first publication that we put out in 1983 that describes how portable filters can be used to protect. This one, we were lucky, had 12-foot ceilings in our bone marrow transplant unit, and we were able to hang it on the wall with a large volume of air change rates, and with data that I collected inside. This became the evidence, if you will, that demonstrated that before you turn it on, there's lots of junk in the air, but after a few air changes and after 36 minutes at the air change rate, they pretty much ate up all the particles in this particular demonstration. So we know they work. They just don't work against anything that's coming in from the outside unless it's a really small leak. So we have to know how they work, and certainly there are a whole variety of portable HEPAs around in slide 17. We have them, ones that recirculate the local air. In the lower left-hand corner is one which we are using when we're putting in an access panel for getting MRIs, our magnets in and out of the building because they change as things improve. So portable filters are important for air delivery. High filtration gives us a dilution ventilation. Of course, the solution to pollution is dilution, and it is something that is very useful to reduce the possibility or the probability of breathing a harmful spore or other kind of harmful agent. The volume output is really what we're looking for to determine the air change rate. There is a noise factor. We do have HEPAs, which are 99.97 in those, and they're very, want to be sure they're adaptable for multi-usage, and that's really what we see. Looking at 18, here we're doing some work in the control area of the operating rooms, and it is an area that's sensitive, and we actually attached the portable filter to the structure. And if you could look up by the exit sign at that blue spot, that is a nickel's worth of flutter strip, which indicates that the room was under negative pressure. It sucked and pulled air in. They were doing an electrical closet there, and they were doing some lab repair in the other barrier, so it wasn't in the operating rooms themselves, but yet we take these precautions because the people who would be exposed to dust would go into the operating rooms and do some maneuvering there. Next slide is a hospital I saw in Atlanta. This particular situation, they had the portable filter with the elephant trunk hanging out the window. This pretty much is ineffective ventilation. As fast as they blow it out, it gets sucked back into the room. So we need to know how to use these devices in order for them to be effective. All of the rooms were positive where they had the negative pressure machines. It was blowing out into the corridor. Fortunately, what they were doing was paint. They were painting, and so paint particles were coming out. But again, there's a need for training. Likewise, there's a strong need for training on how to put up barriers. We were putting up barriers here to deal with, in the bottom center picture, roof sink drains, roof drains. And we had to do that right in the clinical space during daytime, and with good barriers, portable filters, and HEPA-filtered vacuum cleaners, and a knowledge on how to use helpful tools in putting up that barrier plastic. It becomes essential, especially if it has to be done during daytime hours. And there's no reason why it can't if the individuals are trained, especially if it's a short project. So that brings us to slide 21. And here in the United States, a lot of training can be achieved by participating in the American Society for Healthcare Engineering, a section on infection control. I've been a faculty of that for more years than I can remember, and I was faculty of my own when we were trying to kick this off in the early 90s. And certainly the guidelines for design and construction of hospitals, which 40-some states utilize for their design and guidance criteria. And of course, Centers for Medicare Medicaid Services uses that as an introduction to all of us that we need to be clear and be aware of what needs to be done. What we're most proud of is the fact that the carpenters in North America, through the union, it created a best practice in healthcare construction. And this training pretty much has taken away my work that I used to do a lot more of, because it's available from the carpenters unions for nothing. And in this case, we have Riley and Tom working in CS, Central Sterile Processing, putting up some barriers for some effort that needs to be done there. Likewise, center picture is where the fellows put reassembled or pre-assembled parts of some barriers to do some work on an ICU on our bone marrow transplant unit. And Ryan on the last picture is trained how to use a particle counter to follow guidance on issues that we felt were important that require particle counting. Slide 22 shows the first class that I taught that were carpenters, and it had everything to do about how we can have effective barriers, and in some instances using portable filters to supplement the air in barriers. There's a great case study in the center picture there that we did on some operating room renovation and how we were able to pull it off without having major delays of surgery, even though we were doing major work in certain operating rooms during off hours. On the next slide, 23, shows what you find when you start moving equipment. Again, I said some of the riskiest times are when we salvage the equipment, the computers, the refrigerators, the toilets, that kind of thing. And the dialysis cabinets are a notorious place for having water damage. Our sustainability efforts are to put water-resistant rock around every water source, including dialysis cabinets. At an institution in California last couple days, we really stressed this as being a sustainability issue, especially for patient safety, employee safety, because as we move that equipment, we don't know what we're going to find. And I've got more examples on slide 24 where we have leaks from our cooling coils. We remove sinks from our ICU. What do we find on the gypsum board in back? Mold growing. So that's a moist environment, and again, another reason why it justified putting some water-resistant rock on those surfaces. Books can get wet. Oh my gosh, this is one they didn't want to throw away, but they had to. Likewise, the MRI cable support, that's all Aspergillus fumigatus, and the carpenters didn't know what in the world I was talking about. But they understood that it was a risk after I finished, and certainly it warrants a good training on how to mitigate that, and that would be simple. That would be a detergent in a bottle of water, and you spray that fine mist. It locks it down just like it locks any kind of particle that is water resistant. We cracks and we knock down the surface tension in an effort to do that. Next slide 25 has to do with airflow indicators. We want to see as the indicator in the middle on top, the air blowing in the wrong direction, which again indicates a need to look at it. In that case, a fan became unplugged that was supposed to exhaust the air. The standard is the metals one on the right-hand corner for our institution. That's what we put on all our barriers as an indicator. It's reusable and unfortunately somewhat expensive, but yet that's what we want to demonstrate. And the bottom chart recorder, the disadvantage of that is they use it over and over and over again. You don't know what you're looking at in many instances. 26 is a picture of a barrier being used on our bone marrow unit, and the significance of that is the whole aspect of perception. Mom walking by outside wonders, why are you working on my child's room? Oh my God, how do you answer that question? You have to do it. But if I show up, and I've had to do this many times in my career with these environmental containment units or whatever efforts going on in our bone marrow wards or other places, then you need to have an explanation why you're doing. That's why staff, it's important to do that. There are a variety of these kinds of units, anti-room units, and there are also those that when you work on something like a cooler, because the condenser doesn't work anymore, you're not cooling the water, you open it up and suddenly find it full of dust. And we can certainly use these containment units or some kind of barrier or portable filter management of that work when they need to work in that area and clean it up before they start taking it apart. We also have fun with our barriers in slide 28. This was a Carolina hospital in a pediatric ward. They made a cute little plaything of that, but then another individual gave me a picture of how not to use a portable filter, and you never want to dry You'd be amazed what's on that mop. I have many stories about that kind of thing. What we did some years ago on slide 29 is got money from the Homeland Security here in the States and put together an airborne infectious disease management methods for temporary negative pressure isolation. Aha! Temporary negative pressure isolation is exactly what we do when we do construction, and I actually put a sentence on the first pages that says these are the same methods you use not only for containment of bio threats, out clusters of infection or epidemics, but it's also something you do during construction, so you can practice how to do that. And we expect our carpenters, if they're volunteering, to come and help us put together additional isolation wards if that's what the plan calls for. You can get this. It's free. It's taxpayers' money. That is on the bottom. I think I checked that. It still works. We've distributed it around the world to show the people through the World Health Organization how to use duct tape and plastic, and it does provide some useful guidance when work is done. The main thing on slide 30 is to get involved with the concept of anti-rooms. How do we do anti-rooms? We put this in the manual to discuss how we dealt with anti-rooms in a terrorism kind of setting, which is almost like a construction zone, and where to put these anti-rooms and what it means for fire management in the facility if we have them. But the next slide gets into the whole aspect of what we need to do to certify a portable filter. I think we have around 40 of them, and we have a company come in and certify them all at once. I used to do that, but it got to be such a pain. You can find 10 of them, you can't find 10 others. They're willing to pay people to do that, and it becomes a different deal if you're not trying to put out fires all the time. So you need policies and procedures. You should have a statement that says they're routinely evaluated, and the volume output should be determined, and that's Q equals velocity times area. So if you've got a 2-foot by 4-foot opening on that portable filter and it's moving 100 cubic feet a minute, you've got 800 cubic feet a minute that you use to determine your air change rates. There's a criteria in here for checking the filters as well as looking at the output in locations as well as how to maintain it. What do you do with the portable? What do you do when you need to transport them? Change the pre-filter. Don't worry about the main filter because it pretty much locks those particles in place. Slide 32 is an example of a policy, a protocol that a mechanical company had to follow in an effort, again, to use HEPAs in our facility when we were doing tie-ins, when we were tying buildings together, and we needed that HEPA filter. It gives some specifics, and when Peggy here comes around with a portable filter, particle counter, she can determine if there's any leakage. She can check the flutter strips to see if they're working. In her case, in this situation, on slide 32, we're actually remodeling or expanding our neonatal ICU, and she was charged with that area to make sure it's working right. Phasing is a big deal on 33. This was I think it was a 6 or 7 phase project. That would drive most people crazy, and in some instances, we hire a nurse to help coordinate the places like the ICU. But multiple phases like this are very, very difficult. And sometimes it's easier just to move all the patients if they've got the room, or in this case, they cut the project in half and flip them around just back and forth in order to get this pediatric facility, pediatric wing in our hospital taken care of. Henry here was a big help in coordinating when patients could be moved, the criticality, so that there's enough staff to do that. So it's coordination is an essential concept. Now, this particular slide, 34, is a way that we can ventilate anterooms. You can, if you've got a portable HEPA, you can blow it out and suck the air in from both doors. or if you got a portable HEPA, you blow it in and create positive pressure in that space. That then may become a best place for donning and doffing. Likewise, if there's no portable filter, you can get the air blowing right through. And in some contractors, because they recognize this as a big deal, especially in operating rooms or bone marrow transplant, oncology, neonatal ICU, if they're using a concept like an ante-room, they put in sensors, pressure sensors that actually beat the contractor after hours. That's a big deal that needs some additional explanation that I can't talk to today, but that's not the best practice that we would really want to promote. And how you bring the contractor in becomes a really big deal, especially if you don't make the right call. We don't want Fox, we don't want to yell fire too soon, because again, we need to make sure we understand why the pressure dropped or increased, if that's the goal of that pressure monitoring device. Slide 35 shows some basic precautions covering debris. Make sure that that is done. Portable filters in the corridors, outside of rooms, in patient care areas, walk-off mats that should be changed more frequently, and signage. Signage that demonstrates, again, that it's a construction area, keep out, and an appropriate airflow monitor that indicates which way the air is flowing. Slide 36 shows a project we did where we were changing out tomographs. We had a linear accelerator, I believe, in this room, and we were putting in a tomography type of a gadget, and they needed to realign the slab. So they had to jackhammer out the space and put this new concrete in. The problem was the equipment room. The equipment room is where we had our bradytherapy equipment, our simulation room, and what we worked out, because this room was used about 10 or 12 times a month, and they couldn't move it. There would be a really big deal just due to the regulations involved with radioactivity. So what we ended up with on days of treatment, which were scheduled, the guys knocked off early, let's say 2:30 in the afternoon. They cleaned the space up. We brought in portable filters. We brought in the equipment that was to be used. And when we got down to baseline, what the particle counts were in other rooms in that particular radiation therapy unit, we went ahead and moved the patients in. So here we've got a cooperation that we make it work, because these aren't the highest risk cancer patients, but yet we don't want to be cavalier about the way we do things. And unfortunately, in these United States, the true regulators are lawyers, and we settled a case on the East Coast last week where a young man with leukemia developed an aspergillus infection in the eye, and his room butted up to a construction project where they were remodeling a dialysis unit, and the pictures they could show, mold on the wall, was amazing. So unfortunately, we're not going to know much more about that than this, because it is protected by client lawyer privilege. So unfortunately, that happens. Next slide, we see some exhaust vents. We had some of these exhaust vents fail in our dormitories, not the hospital. When it failed and it's cold outside, like it was when I took this picture, that cold air spills back in, freezes pipes, and pops them. Not good. We like ducted exhaust systems to control the airflow. And if you look at the ducted system on the left, you'll see a hood over the flex duct. And what you don't want to see in slide 39 is, as I found one time inspecting a construction site in my house, not my hospital, I mean, and this is what I saw. That duct work was completely disintegrated. It was not doing its job. That supervisor was discharged because he was not doing his job that we mandated to him. So again, it's one of those things where our project managers can discharge an employee, send them back to the bench, if you will, if they do not know what they are doing. And in this particular case, there's no excuse for not doing it right. And that's why now we mandate that all of our flex duct have caps on the points where they vibrate so that they don't come apart. Likewise, this is what I saw in Atlanta some years ago, where they were doing work in the fan space where they had the big big fans. In this particular situation, it was over 90 degrees in there, and they decided they were going to put a 4x4 in the door to ventilate that, to keep it cool so the guys could work. There were 4 fans, 2 patient, 1 surgery, 1 public. Which one did they pick? They picked the public one. Was that good planning or luck? But yet, if you're going to steal air from the hospital to do something like this, know what you're impacting. You never want to take that away. Never want to take that away from a critical patient care area like an operating room. There are a number of things that you need to do in a hospital to manage it. I've been involved where window seals don't work, where the entrance of the hospital isn't pressurized, where there are leaks because of the building wasn't put together right, road cleaning wasn't kept up. I mean, you could go on and on, but these are examples. What are you going to do at the job site you're looking at where we were building our hospital when a tornado comes within a mile? Which happened? There was an awful lot of airborne dust. It's very difficult to control anything at 40-mile-an-hour, 50-mile-an-hour winds. Making sure the filters are properly installed and buildings are pressurized will protect the neonatal ICU, which is in the picture, as well as the surgery centers and ambulatory surgery centers around this campus. So it is something to consider. Number 42, slide 42, shows tie-ins. Tie-ins are unique because in this case, tying one building into another can create airflow control problems. And when you see on some of the windows the green moss growing, you know that they've had water exposure, and being wood windows, they certainly could have mold. So tie-ins are very important to control, and there are some specific measures that could be followed. You see some of them there, and we just need to mitigate those before those walls come tumbling down. Next slide, dumpsters, where they're placed. I've seen clusters of infection associated with dumpsters in California and Indiana. When you have, in the case of the container units on the right side, they didn't have lay down space for their supplies, so they were brought their own containers in. And certainly the dumpster needs to be very carefully managed so that it doesn't become a source of mold right by the front entrance of the hospital. 44 shows where we were tying together an operating rooms and a bone marrow transplant ward was on the floor right above. Under these kinds of situations, when they had to take the brick off of some columns, the noise was unbearable in the patient room. We had to find another room for them with portable filters to bring it up to the air change rate and filtration that's necessary. That is best practice for managing BMT patients. But in this case, we had to move them for a very short period. It only took a day to do one column, and I think there were 4 columns there. So they had to move the patient several times in an effort, again, to mitigate the noise problem, but yet keep the patient safe using portable filters. Situations like 45, you don't use that wood inside the project. It shouldn't sit in water. It can sit out. You can use it outside for scaffolding and whatever else you might need it for temporarily. And likewise, you shouldn't see scaffolding sitting in a pool of water. Who's going to pay for the leak if you puncture the membrane? This was a surgery center, outpatient surgery center, but these are symptoms of sloppy work. And by the way, why is there water pooling up there? So these are issues that you don't want to stumble onto, and you want to make sure you're ahead of the game. 46 talks about control, pressure management, transport. Again, how do we do it? Avoid tractor. The bandy doesn't see it. It's not a problem. So we want to make sure you don't see tractor. Water damage protocols and training of supervisors. Whenever we're finishing up a project, one of the things that happens, and it's happened in major institutions, sprinkler heads go, you don't have time to get the equipment, so we have water damage carts, water response carts that has vacuums, boots. I never know where the water's coming from. It has extension cords, all ready, squeegees to get the job done as quickly as possible, because if you don't take care of leaks, like this was in a critical care ward of a washing machine that they put in for the benefit of the patients and the long-term care, my goodness sakes, that's a lot of mold. But a slow leak will do this. The slow leak will do this, and it can happen behind the ice machine. It can happen in a bathroom with a slow leak and now nobody uses it, like, for example, a residence room. Again, we need to be careful when that humidity comes up to meet the criteria for mold growth. Ductwork. Keep the ductwork clean. Protect it. I sit on the National Air Cleaners or Duct Cleaning Society, and while visual is important, you shouldn't be able to write your name in it. What is it that we're really trying to do? And SMAC, the Sheet Metal Association, really has some visual guidelines for that. Informing the employees is really a good thing. They put signs all the time in elevators. There are sign boards or project boards. Keeping the employees informed and letting them know that you've got the best efforts going forward really is reassuring, not only for employees but also for those that are there with their loved ones. 49, we like enlightenment. Keith is an enlightened supervisor, for the job. Radio phone in one hand, duct tape in the other, going around and making sure that critical equipment isn't being contaminated by shrink wrapping it, as well as making sure all our ducts, our barriers are in a row, if you will. Value engineering, in the Association for Practitioners of Infection Control put together a manual, best practice for infection practitioners. We have several chapters in that, and certainly is one to discuss about how best to deal with construction. Your safety meetings are the best place for infection prevention to be involved. There should be a placekeeper for that to voice the concerns of infection preventionists and so on. So we should also have forms for risk assessment that describe areas affected, work description, start, finish, times, work hours, notification, permits, like is a infection control permit required for this one? Is there noise and vibration aspects that raise the perception, and who are the people we need to contact, and what are the meeting times? So these are all things that become very important when dealing with construction best practice, and keeping it clean is a huge part of that. And when you're jackhammering very thick walls in the radiation therapy department, that really creates problems, and ones that we have been read the Riot Act from patient relations in the past. So how you notify or move patients away from that noise that has to be done all night long is really something that will raise perception. Outages. There are planned and there are emergencies. Where are the critical areas? Which ones cannot tolerate outages, like operating rooms or bone marrow transplants? We keep backup motors on hand, fan belts, bearings, and if you're particularly enlightened, you're putting in fan walls with redundant systems, and also portable filter contingencies, which we have a lot of sitting around. Water coming into the building is really the source of mold, and it happens so often during renovation construction. We need to be aware when it grows. In the case of the bottom right-hand picture, we have fomites, those inanimate objects that are sitting right next to mold colonies, and if they use those brooms out in the corridor, they're spreading the word of spores, and that's not good. So water damage has to be recognized. It needs to be mitigated so that you're not leaving an open, festering spore colony like you see creating problems. There are all stories associated with water management in healthcare, and I get to do that next week in Milwaukee. So it is a topic of import for hospitals. And those flood carts can't say enough for them. There's one on the right, I think, what came from a Texas hospital, and the one on the left is the one that's used at the University of Minnesota. And you can see the squeegees and some other things that are in place to help manage water so that it doesn't get to a porous surface, which generally just needs water to grow whatever spore is in place. So it is something that is somewhat troublesome. One of the issues, again, that's really a big deal, again, with the interim life safety, is they'll keep these sprinklers active and vulnerable. They now are visible, and somebody coming in with a ladder over the shoulder can hit that and pop that sprinkler or bump it with something else, and all of a sudden you've got a lot of water coming in. So on our job sites, we have a modified hockey stick on the right side. That's that lighter piece of wood, and that is sharpened at the end, and it can be used to shove that small star-like item on the bottom of the sprinkler head back up and stop the water. There is actually a commercial project for that. And if you notice the key up on top, that's the key for the room where the shutoff is. We insist that all the contractors know where the shutoff is before water shutoff, before they start the job. We have 4 books of water shutoffs. So you need to know where it is in the area you're doing work in order to avoid a disaster. And I could describe some to you, but again, I'm running out of time. Water detection devices, this is good for the hospital to have. Their pins, their conductivity, their infrared. And I can't say enough good about the infrared technology, because you can actually see rather than feel where that water damage is. And the infrared works on evaporative cooling, and that's what you see in slide 58, where the heat is coming through the walls and the cold steel support beams are in there. Condensation is occurring, and that's why you end up with mold on the right-hand side of the picture. That mold, again, due to condensation, and especially bad on the diffuser in the panels up above in this particular slide. The mold happens underneath a sink. The one on the right, again, was an Atlanta hospital where they didn't have good plastic laminate sinks, where they weren't sealed, water seeped down. I can't imagine the number of spores that you'd be releasing into the environment by pulling it up. The bottom right hand is a Minnesota hospital, not mine. And while there's mold growing in there, there's an exhaust fan also, because it's dissipating the heat from a flash sterilizer in operating rooms. What I worry more about this particular slide is that mark, that sort of mark on the left panel of that right-hand side, lower right-hand side picture. And is that an individual saying, I wonder what this junk is? Well, I pretty much say every time I show this slide that Aspergillus andes got to go up into the oncology ward and clean out a toilet because it's plugged. So there's your vector now walking through the hospital, shedding spores if they don't take precautions. The nice thing is you can close the door and come back and deal with it when you're prepared. Sampling, I've got a few slides for monitoring, and slide 60 shows a very common device used by industrial hygienists that identifies spore morphology to make a tentative genus identification. The lower right hand is Aspergillus fumigatus spore head. You can see it there, and prolific spore production. Must have been good food source. But that's what we worry about, prolific spore production. They say one head can produce 10,000 spores. Neither here nor there, it's something to be respected in a hospital environment. So 61 gives us some interpretation. We always say don't sample unless you know how to interpret your data. Indoor-outdoor ratio, you should always see lower inside than outside, unless there's an activity that's raising those numbers up, and then you got something to talk about. Indoor problem areas different from non-problem areas, so we always do a comparison of Ward A to Ward C. Indoor organisms are not similar to outdoor organisms unless you have just a lower number because we shed. So we essentially bring in as vectors whatever spores we have outside. And if you want, you can always try aggressive samples on things like carpet to really raise the numbers and raise your concern. So on 62, you have surface sampling strategy. Indoor problem compared to an indoor control. You have a plate control to make sure your media isn't contaminated, you're not contaminating it during transport. You're always looking for suspected poor maintenance, dusty floors. Worked with a hospital that had contaminated laundry, and every place we checked, all the laundry rooms were fine, but we found the phycomycetes in the dirty corridor where the laundry was being stored at this particular institution. So we need to be fully aware that where we can expect to find microorganisms and compare it to some other place. And then we always look for water damage. When we have that vinyl on the wall pulling away, when we have ceilings that are stained, when we have fuzzy stuff in the room, don't discount it as not being mold. You have to be suspicious, especially when your risk population is at hand. Surface sampling method 63. We can use what the industry calls Rodak, but it's generically called the surface contact media plate. It's a nice way to lift the spores off of, or microbes off of the surface and grow them up. It's a better method than swabbing because there's a better recovery rate, and we really don't know how to quantify swabs, where you can easily count a flat plate, and there are some public health standards associated with surface contact media plates. We like tease tapes if it's dusty because we can make almost a real-time analysis, especially if we bring our microscopes with us. And then there's the vacuum method, another viable method, but that's kind of gross. It would be more yes or no. Is it really, really dirty, or what are the organisms that would be there? And we do that often when we want to look crack and crevice in laundry storage rooms as one example. Next slide brings us back to where we began. We covered a fair amount of ground. We've certainly, I talk fast. My cup runneth over. I apologize for that, but there's a lot to this that I haven't covered, including the water quality issues that are very important in managing the environment of patient care, especially when you have super susceptible individuals that you're monitoring closely microbiologically. Water quality issues does cause problems from infection, as well as a confusion clinical staff when they colonize some of our patients. So as we finish up on slide 65, if anybody's interested in asking a question, I'm game for that. This is a new medical building the medical school building putting up next to our hospital. We certainly know how to put 10 pounds in a 5-pound pail, but yet we need to be very cognizant and aware of the risk areas, which might include false positives coming from laboratories. So with that, I finish. I apologize for missing an awful lot simply because there's a lot to talk about, and I will turn it over to Lynn at this time.
Well, goodness gracious, that was an incredible amount of information in a very short time. Might I advise our audience, you better hang on to the slides from this presentation, because I can tell you will be referring to them over and over again, because construction and renovation will never go away. So with that, thanks, Andy, for a wonderful presentation. Now, for our audience, we do have 2 more slides. Slide 66 is, again, capturing the Weber Teleclass schedule for the month of May. And as you can see, we've got a good variety of topics. One on May 27th is to be announced, so stay tuned for that. But all of these are excellent, excellent topics for today's world of infection prevention. And finally, as we always do, we do want to extend our thanks to the patron sponsors for the Teleclass series. This group is Diversey, a well-known company that not only provides products and equipment, so to speak, for environmental infection control, but also has a good source for information and training, so that's always a good thing to do. Virox, another excellent company, many good products, and also finally the World Health Organization. There is the website for their Infection Prevention and Control Global Unit, also another good resource for information for infection prevention. And with that, on behalf of, Paul Weber and Dr. Saeed Sattar, who are the founders and organizers of the Weber Teleclass series, I'd like to say thank you all for being a part of today's Teleclass, and we will see you at the next Teleclass offering. Take care and have a great day.